When you're learning how to do trig sub, it can be very daunting at first because you're shown these three different types of integrands that you may encounter, and then you're given three different outcomes for your trigonometric substitution that you can choose from and kind of piece together an answer. And it can be very difficult to understand at first which one is ideal and which one you should be using for each situation. But it doesn't have to be that difficult. In fact, it's actually quite easy to remember. So if you just use this trick, you should have no problem. So the first thing to notice here is that we've got two different s's here. We've got secant and we've got sine. And what we also have is two different subtractions. Now, subtraction obviously starts with s, and both of these also start with s. So if you just remember that it's subtraction, therefore it's one of the two s's, you should be okay. And that of course leaves the remaining plus as the tangent, the only remaining option. Now if we break this down even further, once we know that this is tangent, we can go ahead and stop thinking about that, sorry. And we can focus on the two s's, secant and sine. Now, first thing that we have to remember is that typically you learn sine much before you learn secant. Secant comes as 1 over cosine, and typically you don't learn that until you already at least know what sine and cosine and tangent are. So you will have learned sine before you learned secant. And that's important because if you look at the pattern that corresponds with sine, right here, a squared minus x squared, you'll notice that a is first. A also happens to be the first letter in the alphabet. So when A is first, the first letter in the alphabet is first, the one that you learned first, being sine, is that one. And then that of course leaves secant, the one that you learned last, to be x squared plus a squared. So to briefly recap, if it's got a subtraction symbol, you know that it's one of the two s's. If it doesn't, then obviously it's tangent. And if it's a squared first, then you know that it's sine because a is the first letter in the alphabet and it's first here. And we learned sine before we learned secant. So that's my quick little cheat to kind of easily memorize which one of these patterns goes along with which one of our trig substitutions. So now that we know that, let's go ahead and jump into some practice problems. This first example is something that I ran into on a quiz when I was taking Calculus II in college. And this one, as you can see, has a subtraction there, so it's going to be one of our two s's, either secant or sine. And it starts with our variable in front, so that's t squared minus a squared. So because a isn't first, it's not sine, this is going to be x equals a secant theta. And more specifically, in this case, we'll say x equals a. A is this number, but remember, this is a squared. So what this really is 2. This is a 2 secant theta. And now we need to get our dx. In this case, it's written as dt, so we'll go ahead and course correct that once we get there. And the derivative of this is 2 secant theta tangent theta d theta. It's very important that you remember the d theta there because we'll have to include that as we write this out. So let's go ahead and rewrite this now. We've got dx, which is our dt, and we're going to pop that up top because it's going to go right in here as if it were our dt. And it has a 2, so that 2 I'm going to go ahead and put out front. So we've got secant theta, tangent theta, and I'll pop the d theta off to the side there so we've got some room. And now we've got our x, which is t, and we're going to cube it. So we've got 2 secant theta. So that will be 8 secant cubed theta times the square root of our x again, t squared minus 4, which is 4 secant squared theta minus 4. And now just to simplify this once more, we've got this 8 here, and we have a 4 under a square root, and that will become a 2 because the square root of 4 obviously is 2. And the way that this breaks down is what we're going to do is we're going to bring a 4 there, and we'll multiply that by secant squared theta minus 1 inside there, which is the same as saying 4 times secant squared theta minus 1, like that. And so this is just 2, and we'll go ahead and pull that out underneath here. So we'll pull this 8, and then we'll multiply it by that 2 that we got over here. And so what this really is 2 cancels with that 2, that's just 1 over 8. So 1 over 8 times the integral of secant theta tangent theta over secant cubed theta. And now let's look in here. We've just decomposed this into the square root of 4, which is 2, times square root of secant squared theta minus 1. Now secant squared theta minus 1 is actually tangent squared theta, and it's under a square root, which means it's actually just tangent theta. So we can go ahead and replace all of this here now with just tangent theta. Go ahead and rub this out, and then we'll put our d theta there. And now we've got some crossing out to do. We'll notice we've got a tangent up top, a tangent on the bottom, a secant up top, and a secant cubed down there. That secant cubed will become a secant squared. And now we've got 1 over 8 times the integral of 1 over secant squared theta d theta. Now, secant squared theta on the bottom there can also be written as 1 over cosine squared theta, which is the same as saying 1 over 1 times cosine squared theta over 1, which is just cosine squared theta. So what this can be simplified to is 1 over 8 times the integral of cosine squared theta d theta. We have a cosine squared theta d theta, and this is something that we don't know how to just directly integrate, but what we do know is how to step that down. When you run into a cosine squared theta, we can rewrite that as a 1 plus cosine of 2 theta all over 2. These two things are equivalent. And so then we have 1 over 8 times the integral of 1 plus cosine 2 theta over 2 d theta. Now, of course, we'll bring this 2 out. So this is 1/16 times the integral of 1 plus cosine 2 theta d theta, which then, once we perform the integral, becomes 1 over 16 times theta. The integral of cosine is positive sine, and we've got 2 theta. And the integral, when you do it like this, you have to remember to take care of the middle there, over 2. And because this is an indefinite integral, we must remember to plus c at the very end. Now, although this looks finished, right, we've put our stamp of approval with the plus c on, we're not actually finished. We have theta here, where everything is in terms of theta. And if you remember, all the way back here at the top, we started the question in terms of t. And so we can't just leave it in terms of theta. Instead, we have to figure out what to do with that. And the only way to do that is to draw a triangle. So we've got triangle, right triangle with theta there. And if we go all the way back up here, remember that we let t, or x, equal a secant theta, or 2 secant theta. So we can say t equals 2 secant theta. And from here, we can find that secant theta equals equals t over 2. And cosine is here to here, whereas secant is the inverse of that. It will be this over that. It will be hypotenuse over adjacent. Now, to find this, we just have to apply Pythagorean's theorem. And what we'll find there is that we have 2 squared minus 4, or sorry, t squared minus 4. And that, of course, comes from t squared equals, we'll call this x squared plus 2 squared. And so then find x, we have to find x squared equals t squared minus 4. This is your 4. X equals the square root of t squared minus 4. And that's how we got to that. Now, we come back over here. We've got 1/16 theta, which theta, if you recall, we have secant theta equals t over 2. So that means that our theta can be secant inverse of t over 2. just like so, plus sine 2 theta is another trig property, and it is actually 2 sine theta cosine theta, and in this case it's over 2, but luckily for us that 2 will cancel, and so what we are left with is actually sine theta cosine theta. So we can bring this down, 1/16 secant inverse t over 2 plus sine of theta is this over that, is opposite over hypotenuse. So it's going to be the square root of t squared minus 4 over t times cosine theta, which is adjacent over hypotenuse, which is 2 over t. And then don't forget the plus c at the very ends there. So what this simplifies finally down to is 1/16 times secant inverse t over 2 plus 2 square root t squared minus 4 over t squared plus c. And that's it. That's our full-fledged answer to this trigonometric substitution question. But yeah, with trig sub questions, generally just remembering that if you have a square root and it's x squared minus a squared, or if it's a squared minus x squared, because it has a minus, a subtraction symbol, it will be one of the two that starts with s. It will be either a secant theta or it will be a sine theta. Remember, if a comes first, it's sine. If x comes first, it's secant. And of course, if it has a plus, then it's just the tangent option. Another big thing, and this is less so to do with trigonometric substitution and more so just with trig integrals in general, is remembering your other trig properties, like cosine squared theta equals 1 plus cosine 2 theta all over 2, or sine squared theta equals 1 minus cosine 2 theta over 2. Those two are massively important when you're completing any integral with trigonometric properties in it. If you know these two, it will get you out of a bind almost all of the time. And then of course, this other one where it's once you integrate and you end up with something like secant 2 theta, because of, you know, what you've done here, remembering that that is sine 2 theta, remembering that that is 2 sine theta cosine theta is immensely important, as it really helps us, particularly in this step here, come up with a final solution or a final product that we have to work through. But yep, that's a couple of tricks that I've had from Trig Sub. I hope that these really help. They've helped me, a couple of my classmates. They made everything significantly easier when it came to Trig Sub. I didn't have to think about anything. I would just look at what the sign is it a plus or a minus, and then is it sine or is it secant? And it was really smooth sailing because of this trick. If you have any questions, please let me know. If you have any other problems you want me to try out, please put them in the comment section below.